Okay, now in this video, we want to look at some laws of logarithms, alright? And this particular video, I'll be talking about some bases, some change of bases of logarithms. So I'm going to focus on two parts. The first one is when we have a fraction involving logarithms, that is the numerator is a logarithmic term, okay? And the denominator also is a logarithmic term, or I can say expression. So we have them like that, and you see that the base of the numerator is the same thing as the base in the denominator. Okay, so when the bases are the same in both cases, alright, maybe the number will not necessarily be the same. In fact, if the two terms are the same exactly, we just have one. So maybe the bases are the same, it must be the same, then this is what we are going to have. Just take the number in the numerator and then it will just still remain, then the number in the denominator will now become the new base. We are going to prove this, alright? Okay, so in the second one, it's just like more like a reciprocal law, where we're going to have, when you take the reciprocal of a certain logarithmic expression, then it is going to give us this, that is, the base and the number interchanged, just like that. Okay, great. So I'll go ahead and prove this just as they are, right? Just using letters. Okay. But that's the general approach. So the particular examples will be when we use numbers to show them. But the rigorous one is actually very nice. That's the general one. Okay, so let's just go ahead and do that. So proof number one, let me just put it down here. That the logarithm, we have to show that when we take the logarithm of a to base b divided by the logarithm of, let's say, c to the same base b, alright, that from here, that this is going to give us the logarithm of a to base c. So we just go ahead and prove this. Let me just put it down there. Proof for you guys. Alright? Okay, great. Now, looking at the numerator and denominator, I would like to give them some name. Okay, let me say let the numerator, that is, the logarithm of a to base b, be equal to x, alright? And I'll also give the denominator some name, okay? But from this relationship, that means that, okay, let me also give the denominator some name so that I'll rewrite it before I continue. And also let the logarithm of c to base b to be y, alright? That means that in this place, we're going to be having x. And here we're going to be having y. So it's just like saying x over y is equal to this. Alright? Okay, great. Very nice. So since we've gotten that, that is it. Alright? So it means that from here, maybe if I just give them some name, let's call it 1. And I'll go ahead and call this one 2. So we see that from 1, okay, using our basic laws of indices, that from here we can write this in the index form as b raised to the power of x, then we equate that to a. Okay, great. So looking at this equation, that b raised to the power of x is equal to a, alright? What I would like to do here is to go ahead and take the logarithm of base c to both sides. So I will just say, let's take the logarithm of base c to both sides. So that will be, let me clean this up. So this is a right here. So this is going to be the logarithm to base c, alright? And here also the logarithm to base c. So since the bases are the same, that means we have actually not changed anything because we are doing it to both sides, alright? Okay, great. So from here, I'm going to rewrite this in a better way over on this side so that we see it properly. Okay, great. Now you see that this is the power in the number, so we can take it to the front of the logarithm, alright? And that is going to be x times the logarithm of b to base c. So this is b to base c, and we equate it to logarithm of a to base c. Okay, maybe we just stop there and call this some equation. Let me put it down as 3. Alright, now from 2, we also see, from 2 here, we also see something nice, alright? That if I decide to take the logarithm of base c on both sides, we're going to be having, okay, from this c, we can see that we're going to have, let me just put it down, b to the power of y is going to be c. That is, b to the power of y is going to be c. So I will say let's go ahead and take the logarithm of base c to both sides. Okay, so we know that the number here and the base here, they are the same, alright? So the logarithm of base of c to base c is going to be 1. Okay, so on this part, we're going to just have 1 here. Now, on this other hand, we are just going to put down the y in front. So push the y to the front and enter with the logarithm of b to base c. Okay, so we equate it to that 1. Okay, very nice. Now from here, I would like to make logarithm of b to base c to be the subject of formula. That is, I would like to divide both sides by y. Alright? So by doing that, we're going to have the logarithm of b to base c to be equal to 1 over y on this side, because this y will just cancel out with this one. Right? They will just cancel out nicely like that. Okay, very nice. Now we see that from this equation, maybe I just put it down as 4. So from equation 4, we see that logarithm of b to base c is 1 over y. So if you make a substitution to equation 3, you're going to see that logarithm of b to base c, which is this part, right? The whole of this. That right there is the same thing as 1 over y. So in place of that, I'm just going to put down 1 over y. Okay, so when we do that, I don't want to write a statement there, right? Just substituting equation 4, or substituting logarithm of b to base c from equation 4 into equation 3. So we're going to have x. Then in place of logarithm of b to base c, we're going to put down 1 over y, alright? So that is a product with 1 over y, and then we equate it to logarithm of a to base c. Okay, great. So we see that x over y is something as x times 1 over y is something as x over y. And you know what? Since this was equal to x and this was equal to y, this shows that x over y is logarithm of a to base c. That was from the substitution that we made, alright? So this means that x over y, which is something as this top and this bottom, alright? Okay, maybe I put it down here. That x over y is something as a logarithm of a to base b divided by logarithm of c to base b. So since it's the same thing as this fraction, and that same x over y is the same thing as this logarithmic term, in fact, this one is equal to this one, and hence the proof, alright? So that is it for the first one. Let's go ahead and prove the second one real quick. Alright, now in order to prove this second one, I would like to use one of these to get the other one. That is what proof is all about, okay? That was what I did initially. I was using the fraction to get this other expression on the right hand side. So here I'll be using the right hand side to get the expression on the left hand side. We can also do it conversely, but I'm only going to do it in one way. Okay, great. So to take the logarithm of b to base a to get this, in fact, let me just put it down as proof. Alright, so we want to prove that this equation is true. Okay, we are not actually solving for anything. Alright. Okay. Now, as I said earlier, let the right hand side, the logarithm of b to base a, be x, right? That means that from our basic laws of indices, we're going to take this to this power and we equate it to b, right? That is changing it to index form. So that will be a raised to power x, and this is equal to b like that, right? Okay, great. Now, the next thing I would like to do is to go ahead and now make 1 over x the power of both sides. That is to say, take the x root of both sides. So what I'm doing that is because I want to make a the subject of formula. So in order to get rid of this x on this left hand side, since it's just a power, okay, you have to go ahead and divide it by something that will make it cancel. So this is it. We will go ahead and take the power of 1 over x to both sides, right? 1 over x. So that is what I decide to do. And you see here that this 1 over x is a fraction and it's out of the bracket. That is going to be, it's a fraction, it's a power, and it's out of the bracket. So by that we are going to multiply the powers, right? From our laws of indices. So by multiplying the powers, we're going to have x times 1 over x. That's going to be 1. So we're just going to enter with a right here, raised to power 1. And on the right hand side, we're going to just have b raised to the power of 1 over x. Okay, great. Now, if you want to change this back to its logarithmic form, you see that this b is going to be the base, alright? So that's going to be logarithm. Okay, let me put it down on the right hand side so that it shouldn't be confusing. So we're going to have the logarithm to base b, alright? And this is going to be 1 over x, and this is going to be a. Okay, so that is logarithm of a to base b is going to be this. So changing from index form to its logarithmic form, this is what you will have. Okay, now you see here, you observe that 1 over x, okay, is logarithm of a to base b. That means that x will be 1 over this. So we're going to take the multiplicative inverse of both sides, that is the reciprocal of both sides. So by taking that is inverting them, we're going to have x on this other side over 1, alright? And it is equal to, this is going to be 1 over the logarithm of a to base b. So by taking the reciprocal of both sides, that is what you're going to enter with. So you see here that x, which is the same thing as logarithm of b to base a, that same x is the same thing as 1 over the logarithm of a to base b. So since x and x are the same, it means that these other sides must be the same. That is to say, the logarithm of b to base a, right? b to base a is the same thing as 1 over the logarithm of a to base b. And that ends the proof. So we can just go ahead and do this, and that's it, alright? Okay, great. Anyway, thanks for watching. Now, in our next video, we'll be solving some questions, okay, from the unit-pass question that has to do with logarithms. Alright, so let's move back into that.